in this video, we're talking about equivalent ratios when there are missing numbers. So as an introduction, when you have something like this, where you have A colon B, which is a ratio, equals C colon D, and C colon D is also a ratio, it means that these are equivalent ratios. And what that actually means is that there's a similarity in either multiplication or division between these two and between these two, so that's inside each ratio. And then there's another similarity between the first one in this one and the first one in this one. So that's A and C, and the second one in this one and the second one in this one. So here's an example. This is an equivalent ratio. 1 to 3 is equivalent to 4 to 12. And that's because if you do 1 times 3 from left to right, you'll get 3. And then 4 times 3 from left to right, you'll get 12. So as long as you're consistently either going from left to right or from right to left, you're going to have this similarity of times 3 and times 3. And then if you go between the first term and the first term here, you'll do 1 times what equals 4? 1 times 4 equals 4. And then if you take the second terms, 3 and 12, you can do times 4 again. So 3 times 4 equals 12. So there's this similarity inside each of the ratios, and then there's a similarity between the first number and the second numbers. So let's do an example. So here we're missing x. We need to work out what x is so that this truly is an equivalent ratio. So in this case, I'm going to notice that if you go from right to left, from 10 over to 5, and this works because this is the last one in this ratio and this is the last one in this ratio. And if you go from right to left, 10 to get to 5 is 10 divided by 2 equals 5. And because we went right to left, we have to go right to left for this one. So we're going to do 2 divided by 2, because we did divided by 2 here, will equal x. So 2 divided by 2 equals x. Let's just write this over here. 2 divided by 2 will equal x. And 2 divided by 2 is just 1. So therefore we found that 1 equals x. Okay, let's do another one. Here we're missing y. So I notice right away that there's a relationship, this time not between first and last, but inside each ratio. So if I go this time left to right, 3 times what equals 15? 3 times 5. And because of this, if I go from left to right on the other side, I should get the same thing. So 2 times 5 should give me y. Because we don't know what y is, I'm going to write it here. 2 times 5 equals y. And 2 times 5 is 10. So we found that 10 equals y. Let's do one more example. So here we're missing y again. I notice that 4, if I go from right to left, 4 times 2 is going to give me 8. So that means that on this side, if I go from right to left, 7 times 2 should give me y. So I'll write that here. 7 times 2 will give me y. And 7 times 2 is 14. So 14 will equal y. So basically you want to find some combination either between the first and last or inside each ratio that's going to have you end up at what you're looking for. So in this case, y. So here is our final answer.